Hi everyone. Today we're going to be completing our notes on adding and subtracting radicals, as well as multiplying and dividing radicals. Let's begin by considering the warm-up. Let's go ahead and simplify the following expressions. For number one, in order to simplify this expression, we have to combine like terms. So I notice that we have a 5x and an 8x. Those are like terms. I can add them to get 13x. Negative 9y and positive 5y are also like terms that combine to negative 4y. And last, 4 and negative 2 are both like terms as well, just constant terms, and those combine to positive 2. So the simplified expression is 13x minus 4y plus 2. For number 2, I see we have negative 2a and negative 5a. Those combine to give us negative 7a. We have a positive 8b and a positive 9b, which gives us a positive 17b. We have a negative 9c and a negative 4c, which gives us negative 13c. And last, we have just positive 9, and there's no other like terms with that, so we can just add that on at the end, plus 9. So the simplified expression, or answer, negative 7a plus 17b minus 13c plus 9. Adding and subtracting radicals is similar to combining like terms. We can only add or subtract the radical terms that have exactly the same radicand and index. So as a reminder, the radicand is the number inside of the radical symbol, and the index is that number just like on the outside, kind of in that wedge. Similarly to how only the coefficient is affected when combining like terms, only the number in front of the radical is affected when adding or subtracting radical terms. So the blank here is only the number in front of the radical. So let's see how that plays out in example 1. So let's simplify the following expressions. Again, we're looking for radical terms that have the exact same radicand and index. So it's very similar to combining like terms. So here we have 2 root 5. We can say is a like term to negative 8 root 5. So as we combine them, only the number in front is going to be affected. So we can do 2 minus 8 is negative 6 root 5. So just as if this was 2x minus 8x, the x doesn't change, the variable, or the number tacked on to that coefficient, but only the number in front changes. And then likewise, the square root of 11 plus 3 root 11 is equal to, well, the number in front of the first square root of 11 is 1. So adding these together, we have a sum of 4 root 11. So our answer is negative 6 root 5 plus 4 root 11. 1b, here we have 5 root 3 and 8 root 3 can be combined. So we have 13 root 3. We also have negative 9 root x and positive 4 root x. And so those combine to a negative 5 root x. And because we do not have the same radicand in each of these terms, these cannot be combined, and so this is as simplified as it gets. Letter C, 5 root 3 plus root 48. So root 48, I notice, is not completely simplified. I can rewrite the square root of 48 as the square root of 16 times 3. 48 is a product of 16 and 3. So we can rewrite this using two radicals, or the square root of 16 times the square root of 3. And so we have 5 root 3 plus 4 times the square root of 3. So square root of 16 is 4. And then finally, we have those like radical terms. So we have 5 root 3 and 4 root 3 is 9 root 3. And this is simplified completely. And letter D, we have 5 root 20. Well, the square root of 20 can be simplified into the square root of 4 times 5. And then minus 6 root, well, the square root of 45 can be simplified into the square root of 9 times 5. So we have 5 times, well, the square root of 4 is 2. So we get 5 times 2 root 5 minus, and then the square root of 9 is 3. So we have 6 times 3 root 5. So we have 5 times 2 root 5 is 10 root 5. Minus 6 times 3 is 18. So we have 18 root 5. And then when we combine our radical terms, we get negative 8 root 5. All right. Now let's take a look at multiplying and dividing radicals. So to start, let's go ahead and simplify the following expressions using the TI Inspired calculator. So for number 1, here we have the square root of 5 times the square root of 3. In the TI Inspire, you can go ahead and, when you're in the menu, you can hit New, so that's number 1, and Document. If you have something, you can choose to save it or not, and then we're going to add a calculator, so number 1. And I want to simplify the square root of 5 times the square root of 3. So to do that, I can hit Control and then this x squared symbol, and that's going to pull up my square root. So the square root of 5, I'm going to use my arrow key to get out of the radical, and then times the square root of 3. So using that Control and then x squared key gives me my square root. That's going to be the square root of 15. Let's go ahead and fill in for number 1. The square root of 15. For number 2, here we have 2 root 7 times 8 root 3. So back to the Inspire. We have 2 times the square root of 7, arrow key, times 8 times the square root of 3. And we have 16 times the square root of 21. So we have 16 root 21. Number 3, we have the square root of 30 divided by the square root of 5. So in order to get a fraction, I'm going to hit Control and then the divide key to get my fraction bar. And we have the square root of 30. So in the numerator, that's square root 30. To get in the denominator, I'm going to hit the down arrow. And square root of 5. Enter. Gives us the square root of 6. And last but not least, we have 18 root 40 divided by 2 root 8. So again, I'm going to use that Control divide to get our fraction bar. 18 square root of 40 divided by, so in the denominator, 2 root 8. And that's equal to 9 root 5. Okay. So take a moment and look over examples 1 through 4 and see if you notice any patterns. What do you notice about the result of each of these? What conclusions can you draw about multiplying and dividing radicals? And go ahead and write your answer below. What I notice is that we only multiply or divide the number in front of the radical or radicand with each other. So we only multiply or divide, I should say, the number in front, or multiply or divide the radicand with each other. All right, so I'll go ahead and explain what I mean by that in the box below. Multiplying and dividing radicals. When multiplying and dividing radicals, we multiply or divide the number in front of the radicals. So the number in front of, and then we also multiply and divide the radicand. And then simplify. So when multiplying, just in general, if I have a root b times c root d, then this is equal to the product of the numbers in front, ac, and then inside the radical, we take the product of the radicands, so bd. If we're dividing, we take the quotient of the number in front, so we have a over c, and then the radicand is the quotient of those radicands, b and d. Okay. Let's try example 1. We have the square root of 7 times the square root of 6 is equal to, well, the square root of 7 times 6 which is equal to the square root of 42. Letter B, 4 root 8 times 7 root 9. Well, this is equal to 28 times the square root of 72. We have 4 times 7 is 28. 8 times 9 is 72. Well, we can simplify this. I know that 72 is a product of 36 and 2, where 36 is a perfect square. So this is equal to 28 times 6 times the square root of 2. Or 28 times 6 is 168, root 2. So that's our answer. Part C, the square root of 48 divided by the square root of 6. Well, we have the square root of 48 divided by 6, which is the square root of 8. And I know that 8 can be simplified into the square root of 4 times 2, which is 2 times the square root of 2. And last but not least, 12 root 50 over, this would be 1 root 2. That number in front would just be 1. We have 12 divided by 1 is 12. And then the square root of 50 divided by 2 is 25. So square root of 25. And in fact, 25 is a perfect square. So we have 12 times, well, the square root of 25 is 5. And 12 times 5 is equal to 60. All right? So that's it for our notes on adding and subtracting and multiplying and dividing radicals. We're going to get a whole lot of practice in class. So we'll see you tomorrow. Have a great day, everybody. Goodbye.